Okay, we're on solving linear systems algebraically. We're going to be looking at the elimination method today. I've got some steps for solving by elimination here. First thing we want to do is make sure that all the variables and the equal sign are lined up. Then we're going to decide which coefficients you want to cancel out. To cancel out, they must be opposite, so one has to be positive, one has to be negative. And you might have to multiply the equations to do that first. Then you're going to add the two equations. One variable should cancel out. Then you take your answer from step 3 and substitute it back into the original equation. And then last step, just write out your solution as an ordered pair. All right, so let's take a look at this first example here. So I notice that I have a negative 1y and a positive 1y. So what we're going to do with this system is just add up the two equations. Okay, because in doing so, the y's are just going to cancel out. All right, so if I do 2x plus negative 3x, I'm left with negative x is equal to negative 6. And all I need to do here is divide by negative 1 to get a positive x, which is 6. And now I just go ahead and I plug my x back into one of the two equations. It doesn't matter which one. I'm going to go ahead and do the second one. Negative 3 times x, which is 6, plus y is equal to negative 15. And we just solve for y. So we get negative 18 plus y is equal to negative 15. Add 18 on both sides to get y by itself. And I'm left with y is equal to 3. And so step 5 tells us we should write our answer as an ordered pair. So we should write this as 6, 3. And there you go. That's the solution to this system. All right, let's take a look at another example here. So number 5, it's kind of a poor example because the best method to use would be substitution because we have the coefficient of 1 in front of y. So this would be a very easy equation to solve for y. But I do want to show you that you can use either method for these. So I'm going to use elimination. So what I'm going to do is I'm going to take this whole bottom equation and I'm going to multiply it by negative 8. The reason why is once I get to my second distribution, if I do negative 8 times y, I'm going to have negative 8y here and a positive 8y on top. And if I add the two equations together, the y's will eliminate. So let's go ahead and do this. First distribution, negative 8 times 3x is negative 24x. Negative 8 times positive y is negative 8y. And third distribution, negative 8 times 15 is negative 20. Okay, so I'm just going to now rewrite this equation, the top equation, beneath the other one we had. So this is negative 10x plus 8y is equal to negative 16. And so now what I'm going to do is I'm going to add these two equations together because I have negative 8y plus 8y, so these will cancel. So let's add our x's. We've got negative 24x plus negative 10x, so that's negative 34x. Y's cancel, and my constant, negative 136. Now I just need to divide by negative 34 on both sides, and I'm left with x is equal to 4. So now I need to take my x value and plug it into one of these two original equations. Doesn't matter which one you do. I'm going to go ahead and do the bottom equation. 3 times 4 plus y is equal to 15. 3 times 4 is 12, plus y is equal to 15. Well, what number plus 12 equals 15? Y equals 3. Last thing we should do is make sure we write our answer as an ordered pair. Because remember, the solution to this system is the point at which these two lines intersect, and that point is an ordered pair. Okay, number 6. Okay, so we got to do a few things here So our equal sign and our variables don't line up here. So how I could do this quickly would be to just subtract 2y on both sides for the bottom equation. Okay, so I'll be left with 10x minus 2y, these would cancel out, is equal to 22. Okay, so now I'm going to take this top equation and just rewrite it down here so we can add these two equations together. X plus 2y is equal to 11. All right, now I'm just going to add these two equations together. 10x plus 1x is 11x. The y's will cancel out. And 22 plus 11 is 33. So now I'm going to divide by 11 on both sides to solve for x. Looks like x is equal to 3. And now all I need to do is figure out my y. So I'm going to go ahead and plug that into one of these top equations. I think I'm going to pick the first one, x plus 2y, and x we now know is 3. So 3 plus 2y is equal to 11. Do some solving here, subtract 3 on both sides. I'm left with 2y is equal to 8. So y is equal to 4. All right, so write our answer as an ordered pair, 3, 4. There we go. All right, so other tricks. All right, so let's take a look at number 7. So first of all, we've got some fractions, and that's going to be kind of a pain to deal with. So what we're going to do is we're going to take this whole bottom linear equation and we're going to multiply it by the least common multiple of 3 and 2, okay, which is 6. And the reason why we're going to do this is then we won't be dealing with fractions anymore. Okay, so if I multiply 6 times negative 2 over 3, we get negative 4x. Then if I multiply 6 times negative half, we get negative 3. And don't forget, we have to multiply to the other side of the equal sign as well. 6 times negative 1 is negative 6. All right, now I'm just going to rewrite the second equation down here. So we've got negative x is equal to negative 11 minus 4y. Now, it doesn't matter what we do here. I think I'm going to actually go ahead and solve this one by substitution. So I've got this bottom equation equal to negative 1x. So all I need to do here is just quickly divide everything by negative 1, which is just going to change the sign. So I'm left with x is equal to 11 plus 4y. And now I'm going to substitute it back into, so I'm going to erase this because all I did was solve for x. And so what I'm going to do is take this part, this expression, x is equal to this, and I'm just going to plug it in for that variable. Okay, so I'm left with negative 4 times 11 plus 4y minus 3y is equal to negative 6. All right, I'm going to erase this to give me a little bit more room. And now I'm going to solve for y. So I'm going to distribute this out. I'm left with negative 44 minus 16y. Update the problem, drop everything down. Now I should combine like terms. Negative 44 minus 19y is equal to negative 6. Now I'm going to add 44 on both sides. And I'm left with negative 19y is equal to positive 38 divided by 19, divided by negative 19, and I'm left with y is equal to negative 2. All right, now I just have to substitute the y back into one of the original equations. So I'm going to go ahead and pick the top one here. We've got negative x is equal to negative 11 minus 4 times y, which we now know is negative 2, and solve this out. Remember, we need to multiply these two first. Negative 4 times negative 2 is positive 8. Negative 11 plus 8 is negative 3. So I'm left with a negative x is equal to negative 3. So a positive x is equal to positive 3. Last step, just write this as an ordered pair, 3 comma negative 2. All right, number 8. I'm going to erase this a little bit so I have more room. Okay, so I don't have any variables that are going to cancel, so I could do two things here. I could try to get the x's equal to 20, a positive and a negative 20, or I could get the y's equal to a positive and negative 35. It doesn't matter which one you do. Just up to you. So I think I'm going to go ahead and try to get the top equation equal to negative 20x. So I'm going to distribute a 5. So 5 times negative 4 is negative 20x. 5 times 5y is 25y. And 5 times 1 is 5. Oops. Should be an equal sign. There we go. Now on the bottom equation, I can't just multiply by 4 because I need the first one. I need this equal to a positive 20x, so they will eliminate. So I'm going to multiply everything by negative 4 because a negative 4 times a negative 5 is a positive 20. So my first distribution, I get positive 20x. Negative 4 times positive 7y is negative 28y. And negative 4 times positive 5 is negative 20. So now that I've got these variables lined up, one's positive 20, one's negative 20, I can just add these together and the x's will eliminate. 25y minus 28y is negative 3y. And 5 minus 20 is negative 15. Now I just need to divide by negative 3, divide by negative 3, and I'm left with y is equal to positive 5. All right, last step, I just need to take one of these equations. I think I'll do the top one and plug in my 5 for y. So negative 4x plus 5 times 5 is equal to 1. So solve this, we get negative 4x plus 25 is equal to 1. Subtract 25 on both sides. I'm left with negative 4x is equal to negative 24. Divide by negative 4, divide by negative 4, and I'm left with 1x is equal to positive 6. So my ordered pair here is 6, comma 5. Okay, last two examples we have here today. Choose the best method to solve these. Why don't you guys pause the video and try these two examples, and then I'll go through it here in a second. Okay, so for example number 9, I would certainly choose to eliminate for this example because it doesn't look like I'm going to be able to solve for a variable very easily to use substitution. So I'm going to try to eliminate. Right now, there's nothing I can eliminate, but I can get my x's equal to a positive and negative 12, or I could get my y's equal to a positive or negative 30. It's up to you. I think I'm going to go ahead and eliminate the x's. So I'm going to multiply this whole first equation by negative 3. So negative 3 times 4x is negative 12x. Negative 3 times positive 5y is negative 15y. And negative 3 times 36.4, sorry, is negative 109.2. And now I'm going to multiply the bottom equation by positive 4. Positive 4 times 3x is 12x. 4 times 6y is 24y. And 4 times 39.9 is 159.6. And so now I can add these two equations up because I have the x's eliminating. All right, so add up the y's. Negative 15y plus 24y is 9y. And negative 109 plus 159.6 is 50.4. So divide by 9 on both sides, and I'm left with y is equal to 5.6. Right now, I'm going to erase all these lines here. I can pick either of the two equations to solve for x. So I'm going to take, how about the top equation, 4 times x plus 5 times y, which we now know is 5.6, is equal to 36.4, and solve this out. So 5 times 5.6 is 28. 4x plus 28 is equal to 36.4. Subtract 28 on both sides, and you're left with 4x is equal to 8.4. Divide by 4, divide by 4, left with x is equal to 2.1. All right, last thing, just make sure you put your answer as an ordered pair. So this is 2.1x, comma 5.6. There is your solution. Okay, number 10. What would be the best method to use here? Seeing how we already have a variable solved for it, it would certainly be easiest to use substitution. So I'm going to take this x is equal to 2y minus 2.4 and just plug this in for x. I'm going to rewrite the bottom equation with x substituted out. 3 times 2y minus 2.4 plus 6y is equal to 19.2. And I just need to solve this out. 3 times 2y is 6y. 3 times negative 2.4 is negative 7.2. Update the problem, just going to drop everything down. Combine these like terms, I'm left with 12y minus 7.2 equal to 19.2. I need to add 7.2 on both sides, and I'm left with 12y is equal to 26.4. Divide by 12, divide by 12, and I've got y is equal to 2.2. All right, now I'm going to go ahead and put my 2.2 in for this y. So x is equal to 2 times 2.2 minus 2.4. Multiply this out. 2 times 2.2 is 4.4. Minus 2.4 is 2. So x is equal to 2. So we got my x, we got my y. Let's write this as an ordered pair. 2, comma, 2.2. There's your ordered pair. That's the solution for this system of equation.